Let me describe the scariest kind of production incident. Not the one where everything's on fire and alarms are blaring. The quiet one. The one where every dashboard is green, every service reports healthy, zero errors in the logs, and yet your system is completely, silently broken. By the end of this episode, you'll know exactly how that happens and how to catch it. Let's get into durability, lag, and backpressure. First, durability. A message is durable if it survives a crash. Two mechanisms make that happen. Disk persistence. The message is written to disk before the broker tells the producer, "Got it." So if the broker process restarts, the message is still there. And replication. Copies of the message are kept on multiple nodes. So if an entire machine dies, the data lives on. You only lose data if enough nodes fail at the same time. Now, the producer gets to choose how careful to be, using the acknowledgement level. And this is a classic speed versus safety dial. Set acknowledgements to none, and the producer doesn't wait at all. Fastest, and you'll lose data on any hiccup. Set it to leader only, and the producer waits for just the primary copy. Better, but if that primary dies before it copies the data, it's gone. Or set acknowledgements to all, and the producer waits for all the in-sync copies to confirm. Now you don't lose data unless multiple nodes fail together. The durable default you'll see everywhere, a replication factor of 3, requiring at least 2 in-sync replicas, with acknowledgements set to all. That setup survives losing one whole node with 0 data loss. Memorize that trio, it comes up constantly. Okay, now the star of the episode, consumer lag. Lag is a simple subtraction. It's the position of the latest message in the log minus the position your consumer has actually processed up to. In plain English, how far behind are you? If lag is low and steady, you're healthy, you're keeping up. If lag is growing, your consumers can't keep pace, and every message is taking longer and longer to get processed. And here's why this is the single most important metric in your entire pipeline, more important than error rate. Imagine a fraud scoring service. Its job is to score each transaction before it gets approved. Now imagine it develops lag. It's 10 minutes behind. What happens? Transactions are getting approved first and scored 10 minutes later. The fraud check is now completely useless. And here's the kicker. It's throwing 0 errors. Every service is healthy. The logs are clean. But the system's entire purpose has quietly failed. That's the silent incident. And the only thing that would have caught it is a lag alert. So the lesson. Alert on lag trends, not just on exceptions. Watch the thing falling behind, not just the thing throwing errors. How do you fix growing lag? In order. First, scale out your consumers, add more of them, up to the number of partitions. Beyond that, extras just sit idle. Second, if you've maxed that out, add more partitions so you can add more consumers. Third, make the processing itself faster. Batch things and rip any slow synchronous calls out of the hot path. That naturally leads to backpressure. Backpressure is what happens when producers are faster than consumers and the pressure has to go somewhere. Two philosophies handle it. In pull-based systems like Kafka, the unread messages just pile up in the durable log. The producer isn't affected at all, and that growing lag makes the backlog visible. The system self-regulates. Consumers pull only what they can chew. In push-based systems like RabbitMQ, the broker limits how many messages it will send to a consumer before getting acknowledgements. That's called prefetch. Without a prefetch limit, a fast producer can literally flood a slow consumer until it runs out of memory and dies. Either way, the goal is the same. Pressure should push back upstream in a controlled way, not cause a crash. Two quick concepts before we go. Retention. How long the broker keeps a message. Queues keep it until it's acknowledged, then it's gone. Logs keep it for a set window no matter what, which is what makes replay possible. And schemas. Your messages are contracts between teams. A schema registry enforces that you can only evolve those contracts in compatible ways. Adding an optional field? Fine. Renaming a field and breaking every consumer? Rejected, at publish time, not at 3 in the morning in production. So here's your health dashboard, the stuff to actually watch. Consumer lag first and foremost. Dead letter queue depth. Under-replicated partitions. Latency at the 99th percentile. And broker disk usage, because a full disk means the broker stops accepting writes entirely. That wraps up our foundations. You now know the concepts every broker is built on. Next episode, we zoom out to the whole landscape and map every major broker onto one simple picture. See you there!